Hello everyone. I talk about stratification in winter and its consequences in the Gulf of Finland. And the background of this story comes from the fact that the pycnocline or vertical density gradient is very, very important in the marine systems, and it determines the physical and biogeochemical fluxes, and it is also very important for the onset of life, I would say, in ocean or sea, for the primary production as well. So if the mixed layer is or the pycnocline is shallow or at least comparable to the light-rich zone in ocean, then primary production is very effective. And in the Baltic Sea, in most of the Baltic Sea, we have a deep mixed layer during winter, which is as deep as 50 or 60 meters, much deeper than euphotic zone. But in spring and summer, it is at least in the same order, so the primary production is effective. On the other hand, there are some papers which has reported about wintertime stratification under ice, and these areas are usually near some freshwater source, near some river mouth. Here is one example in the Swedish fjord. And when we see the Gulf of Finland, we have actually several preconditions for such phenomena. We have a very large freshwater input, which is concentrated to the east. We have a elongated shape, and we have also very low temperatures. So sea surface temperature passes the maximum density temperature every year. So the main idea here is that we should also have wintertime stratification in the Gulf of Finland, and that should that should cause mixed layer depth comparable to the euphotic zone, and we should see this also in primary production. And we have done several ship surveys already a while ago. These ship surveys were actually dedicated to study deep layer of the Gulf of Finland, but we saw some interesting results, and then we later did also model runs and checked the ferry box data and also checked the historical CTD data. So our main study area is, I hope you see in this area, really in the Gulf of Finland, in the western Gulf of Finland. These are the sections. And now I show already the sections of temperature, salinity, density, and chlorophyll A. On the left, there is a distance 0. This means mouth, or more or less mouth of the Gulf of Finland, and 120 kilometers is somewhere in the, let's say, in the Sillamäe or this area. And you can see that first snapshot, what we had in the end of December, we had very mixed conditions. This is what is expected from the literature. On the other hand, the second visit, we already see some freshwater patches in the eastern part of the section, and very, very slightly, but still one can see also some higher chlorophyll A values, which is a proxy of phytoplankton biomass. Then next survey in the beginning of February, there is a very clear signal of low salinity water here, which is reflected also in density distribution, and which is reflected also in the chlorophyll A. And you can see the temperature in this case is somewhere near 0 degrees. Then We had some westerly wind impulse. So these colors here in this column, they show, or they correspond to somehow to wind. So if it is blue, there is a more easterly wind. If it is west, if it is from west, it is red. So there was some westerly wind, and this pushed down a bit this Büknok line, and also the chlorophyll A is not so high. But then in the mid-March cruise, we had very high values of chlorophyll A, and this is very well related to the Büknok line. So the main point here is that it seems that at least from this measurements, this onset of stratification happens already in February or so much earlier than it was believed before, and also it is causing onset of phytoplankton, not bloom, but let's say growth. And we had similar observations also in 2014 and 13 and 14 winter, but I don't show them, but they basically show the similar pattern. Okay, to see what is the, let's say, temporal pattern of this phenomena, I show here Tallinn-Helsinki ferry box data from 2 winters. On the left, there is a salinity, and on the right, there is a temperature, and this distance is distance 0 is more or less Tallinn Bay, 70 is near Helsinki. And these are time series from January to March. And you can see that in the beginning of the year, in both years, there is quite high salinity in the surface layer. So the ferry box is measuring salinity and temperature in the surface layer about 4 meters depth. But then already in January, actually, but very clearly in February, some fresh water is arriving to this Tallinn-Helsinki area. I would say Helsinki area, yes. And after some time, let's say after 1 month, this fresh water is spreading to the south as well. And this pattern in 2 years was very, very similar. And to see how this looks in space, I present here modeling results. This is from winter 2011-2012. First of all, there was a westerly wind prevailing, which is causing a kind of blockage of freshwater water advection. Of course, it cannot block it entirely, but it prevents this riverine water advection. So the parameter here is the mixed layer depth. So these are in meters. So it is quite deep. Then when easterly winds prevailed, this allowed to spread all this fresh water along the northern coast of the Gulf to the west. So in this area, already the mixed layer was very, very shallow, and stratification was already on set. And then 2 days later, there was a short westerly impulse, and this current, Ekman current caused by westerly wind, caused this widening of this fresh water area, and this area covered by shallow and productive upper mixed layer. So this is how it works, we believe, or at least this is how our measurements and modeling shows. And there is also some statistics here based on modeling. There is on the left panel, there is upper mixed layer depth, the mean depth in these months. This is November here, December, and so on. And on the right, there is a occurrence of upper mixed layer depth below 20 meters. And you can see that in November, December, this upper mixed layer is very deep, and the shallow mixed layer is very unlikely. In January, there is also already some shallow mixed layer can be seen. Then in February, there is already quite clear occurrence of mixed layer below 20 meters depth in the northern coast, as we saw this from this 1 year example. And in March, there is already more or less the whole Gulf quite often filled by the mixed layer or the shallow mixed layer. And to see what is the or how this looks from the historical measurements, here I show the longitudes on the horizontal axis, and on the vertical axis there is occurrence of density difference, which also kind of indicates if there is stratification in winter or not. And you can see that this 23 degree of degree east is the western border of phenomena, and we believe that it is just the coastal morphology, so that the Gulf of Finland extension gets wider, and somehow this fresher water spreads so that you cannot see very clear stratification anymore. Okay, and here I show the time series, long-term time series of upper mixed layer depth. This pink line is coming from Eastern Gotland Basin, just for comparison, and black line is from the Gulf of Finland. And you can see a couple of interesting things here. First of all, the maximum upper mixed layer depth happens already in December almost every year, and it happens before SST decreases below maximum density temperature. So this means that it is solely it is mainly from the wind mixing is deepening. And on the other hand, the onset of this stratification happens temperatures below this maximum density temperature. So this means that the onset of stratification is not related to the warming, but to the fresher water advection. And I have also here now index. It is quite clear that if the winter now index is positive, then the mixed layer is deeper because of more westerly winds and more mixing. And if there is a negative now, it is rather shallow mixed layer in winter. And over 2 years when we had this ship measurements, these seem to have a positive now. So this means that actually on average this winter stratification is even more common. So these are my conclusions. We report here that stratification at the depth comparable to a photic zone forms already in late January or early February along the northern coast, and 1 month later in the whole Gulf. The mechanism is related to the buoyancy flux coming from the fresher water advection. We can see the elevated chlorophyll A and actually also phytoplankton biomass. I didn't show today, but we also measured phytoplankton biomass there, which is also elevated. And it seems that this feature or this phenomenon is quite common and in the Gulf of Finland. And it also seems that it is related somehow to the North Atlantic Oscillation. And the last thing here is that this study is actually published. So that's all from me. Thank you.